Hello, and good afternoon to everyone. I am Davide Casarin, project manager at White Research, and on behalf of the ALLPROS.eu team, I want to welcome you all to today's webinar. I want to thank you also the set of speakers that you can see in front of you, who will help us talk about strategic open innovation in the chip ecosystem today. First off, before diving in, I wanted to briefly introduce our project. ALLPROS is a coordination and support action supported by the European Commission under the Digital Europe program. And our project has started in January 2023, and its 3 years long activities are guided by this technical coordinator, Trust IT, White Research, IBC, and Open Forum Europe, whose effort led us to being here today for this event. Before we jump in the actual webinar, I should let you know that the event will be recorded and will be available on the project website and YouTube channel, and that we want to hear from you. So we encourage your participation. Feel free to use the chat and the Q&A function of Zoom to let us know if you have questions and comments, and if your questions are addressed to any of our speakers specifically. That said, I think we can now get started with our webinar. Our agenda today will feature presentation showcasing interesting initiatives and projects, and will be followed by a final panel discussion that will bring together all the experts that are here with us today. So without further ado, I want now to pass the floor to Matthew Swerad, Policy Officer at the European Commission of DG Connect. We are very glad to have with us today. Over to you, Matthew.
Thank you, Davide. I'll be just sharing my screen. Is my screen visible?
Yes.
Okay, so good afternoon, everyone. My name is Matthew Schwirap. I am a policy officer within the Microelectronics and Photonics Industry Unit at the European Commission. Of course, today I'll be touching into Europe's initiatives related to open source innovation and open source chip design in particular. This is something that we follow closely from our end and has taken on a new meaning now, especially in light of the European Chips Act, which has been agreed politically on the 18th of April of this year, and which we are now working on implementing. Within sort of the sphere of the European Commission, RISC-V is tackled in 2 domains, both from a microelectronics perspective and then, of course, from an HPC perspective by other colleagues within DG Connect. I'll be focusing mostly on the microelectronics side, but of course there are other initiatives going on in the realm of Euro HPC and so on. So I'll start off with our roadmap. This was set up by a working group composed of industry players and people active in the open source space. It's been out now since last year. It's almost a year old, and the key outcomes of this working group were to build a critical mass of European open source hardware or software, develop set a pathway for developing both open source hardware as well as software, considering their interdependence, address cross-cutting issues, cultivate innovation, and engage with the open source community. You can find the link here if anyone wants to go through it. In a sense, from our perspective, open source hardware is a key sovereignty tool in line with the CHIPS Act priorities. I think, for example, RISC-V as an ISA, I think it's the first ISA that is listed in legislation. It is referred to in the CHIPS Act. A key success criterion for this is for Europe to develop our full-blown open source ecosystem that is also, although European, also open for collaboration and working with other regions. The report has defined a strategic roadmap, which we are now in the process of implementing. We have a short-term roadmap that considers the next 2 to 5 years, which is practically until the end of the current multi-annual financial framework, then a medium-term and also a long term beyond 10 years. And what we essentially aim to do is to create a critical mass of activities that hopefully will enhance and expand the European open source community. Domains where this roadmap addresses, it includes core implementations, accelerators, domain-specific architectures, peripherals for system on chip, ADA, and also software in terms of the tool chain and so on. What have we been doing right now? So we started off in work program 21 with the Tristan project. I believe that Davide will also be going through that in the session after me. Then we had also Isolde that is starting soon enough. Then we foresee other actions in work program 24, 25 up to 27 to keep on developing this repository of open source IP that we are currently building through European member state funding and also industry contributions. Currently, we are also looking into domain-specific activities on RISC-V, particularly related to automotive. More will be coming out, the automotive industry, more will be coming out on that very, very soon. Now, going quickly on the European Chips Act, I will not be going for long. I understand that we have 5 to 10 minutes here to give you a bit of a taste as to what we're currently doing, and I'll be focusing on the design platform. So we know that in Europe we have more or less 1% of the fabless company revenue globally, and that is of course not enough. We are working to cultivate this design ecosystem, and the design platform will be a way for us to support new players to emerge on the market within the context of the European Chips Act. These are the 5 objectives. I will be focusing, of course, on objective number 1, which is reinforcing design capacity by providing this virtual design platform. What we aim to do here is to have a cloud-based environment where one can host EDA tools, IP repository, and so on, supporting companies up to their first prototype, their MPW, and then from there on, we'd expect them to be able to engage with investors and so on. But we're trying to tackle the issue that we see with this value of debt that many of our companies are facing. And of course, as you can see here in a very simplified diagram, I'll be going into a more detailed diagram following this one. We'll have design tools, IP library, PDKs, training, support, design services, etc., etc. We are currently in the process of publishing a report on the implementation of the design platform, and I hope that I'll be able to also share it with you once it's published in the coming days. And we look forward also to your feedback there. So basically, here you see the ecosystem, this proposal that we have, that we are discussing currently with member states. An element of both central platform services, including an accelerator incubation program for startups and SMEs, access to EDA tools and so on. But also, when it comes to the dissemination of open source IP, we foresee this IP exchange, support for validation of open source IP. Our target user group again is startups and SMEs mostly, but it will be all open also to academia and other users. And there will be close collaboration with fabs and common European infrastructure such as pilot lines that will be setting up also in the context of this European Chips Act. And that is basically it from my end. It is only a flavor so far. It's something that hopefully will help you also in your discussion today during this webinar. We're open for feedback. Please have a look at our RISC-V roadmap. Have a look soon enough at our proposal for implementing the European design platform within the context of the Chips Act, and do not hesitate to get in contact should you have any questions or would like any clarifications, or if you have any ideas. Thank you very much.
Thank you very much, Matthew, for your presentation. Indeed, it was a great introduction and a way to frame, I'm sure, our event and maybe also our final discussion. I don't see any questions in the chat so far, So I think we can move to the next presentation on our agenda about the Tristan project that Matthew also mentioned. So this is why I'm happy to invite Davide to take the stage. Davide Schivone, over to you.
Hello, everyone. I'm Davide Schivone. I'm actually working for the Open Hardware Group, which I will introduce during this presentation. And today I want to talk about what Matthew just introduced about one of the first steps that the CHIPS Act makes towards open source hardware. And in particular, I will be focusing on the RISC-V part of the open source hardware. So this is the agenda. We'll start from RISC-V. Why RISC-V in Europe? But first of all, why RISC-V? So RISC-V is a tool that enables open source hardware, and in particular enables that part of the open source hardware that relates with programmable systems, so CPUs, processors, and so on. What is RISC-V? RISC-V is an instruction set architecture, which is open source. This is amazing. There are many of them out there, but RISC-V is basically the most successful one, and as of today. And why that? There are several points that I listed here in these slides, and in my opinion, and ones that are more important is that it's kept very simple. It's extendable, which is a very key feature to make the part of your design competitive. I will talk about it later. It's modular, so that means that you don't have to implement the whole specification in your system on chips or on your system in general, and you can just take care about what you care for. It supports multiple bit width, 32 and 64, the most popular ones. And what is very strong behind the RISC-V is that it's maintained by a foundation, which is driven by the members, which is the RISC-V Foundation, and it has a very active and large community behind it. So in my opinion, those are the points, the 7 points that makes the RISC-V the best ISA to enable open source hardware, programmable open source hardware. What are, let's say, the strengths and the weaknesses in Europe, but in general about open source hardware and RISC-V? So the strengths definitely are around the openness of the ISA, because this enables lower barrier to start making products, license-free, availability of IPs, less vulnerable to geopolitical risk, and so on. But you can see here in the green part of this table on the left. Opportunities. So what you want to do is customizing your ISA to be better than state of the art competitors. You want to work together with other stakeholders on an open source ecosystem to share the development costs and so on, allowing also startups and SMEs to ramp up faster. But of course, there are also weaknesses. So as of today, there are many open source IPs, but not all of them are, say, industrial grade. Not all of them are maintained for a long term. They're not maybe documented. And also the IP portfolio itself is not complete, right? We may have some kind of CPU, some kind of peripheral, but there's way more to be developed to tackle all the market segments and all the possible systems that you want to build. And what Europe wants to build around this ecosystem is critical mass, right? Because you want to the community in Europe to engage all together and to build more and more competitive systems, such that you can compete with other stakeholders coming from other parts of the world, like China or US, which are working hard and fast and ramping up on these systems here, and you don't want to be left behind. So the first step that the CHIPS Act that Matthew introduced starts with is the Tristan project. Tristan stands for Together for RISC-V Technology and Applications. It's a KDTGU project in the European Commission. It has 46 partners all around Europe and started just last December, and it will last for 3 years. It's led by NXP, and actually Rob is a co-author of the slides. And the goal of Tristan is to expand, mature, and industrialize, very important, industrialize the European RISC-V ecosystem for building building blocks that allows the European companies or research centers or educational activities to be, productive since day one. How do we do that? Well, Tristan leverages a lot, but not only open source. So open source hardware, open source ISA, open source software, a lot of open source within Tristan. It will actually define a strategy that actually just Matthew just mentioned it, to build these IPs at industrial grade. So you don't want just to build prototypes or a proof of concepts, but you actually want to build things that the companies can actually use to go in production, make products, and be competitive. Tristan tried to tackle the whole ecosystem, not just the IP, but every IP needs, the software, the full software stack behind. You need EDA tools to translate IPs to silicons and so on. And also it wants to increase adoption of these IPs and such that more people, more engineers, more companies engaged into the cause and start working together on RISC-V. So this slide shows how Tristan is organized. It has mainly 7 work packagings. The first on the left is the one that started first, and it's the one gathering the requirements from companies, from startups, from SMEs, from universities to see what do we need to actually be competitive in Europe, in whatever industrial segment you're trying to tackle, which is automotive, industrial, consumer electronics, and so on. Then once you define the requirements of what you need, then there are the 3 work packages in the middle focusing on the development, on the design and verification of those IPs, targeting different technology readiness level depending on what's the final goal. So there will be the ones focusing on the CPUs or RISC-V based IPs, peripherals to communicate with external worlds or buses and stuff like that, software, which is very important to have all of these hardware working together, EDA tools on the top to help the translation of these into the real silicon, and then you have demonstrators based on virtual prototypes, real silicons, FPGA prototypes, and so on. And at the bottom, you see the Tristan Virtual Repository, which is a place where everyone can gather very fast, and it's a database where is listed all the IPs that Tristan is developing, IPs, software, libraries, EDAs, and so on, where people can actually see what Tristan is doing, what of those IPs or output deliverables are open or closed source, what's their status, what's their goal, who is working on what, and so on. So it's a centralized page to ease the access of the Tristan outputs. So, as I mentioned many times, Tristan believes in open source hardware. And in fact, many, but not all, the deliverables are based on open source IPs. So what we need to do is coping with the weaknesses I mentioned at the beginning of this presentation. That means lack of quality, lack of documentation, maintenance, and so on. And this is where Open Hardware Group comes into play. So Open Hardware Group is an organization that I will introduce later, that many Tristan partners or members work with, and the goal is of the Open Hardware Group is to maintain and support high quality, industrial grade, open source hardware IPs. So it's focused very much on open source hardware IPs for long term. So what is Open Hardware Group? It's a non-for-profit foundation. It has a legal footprint in Canada and in Europe, although it's a global organization. It's driven by the members, and members come from all over the world, not just Europe. And it includes both industrial and academic members that you will see later. And the goal of Open Hardware Group is actually aligned with the goal of Tristan on the open source part, right? Which is developing industrial grade, so with high technology readiness level, IPs based on open source hardware. And as of today, of course, most of them are based on RISC-V. So here you see a panorama of all the members that are actually part of Open Hardware Group. Many of them are part of Tristan, maybe not, many are not, and vice versa. They come from the industry and the academic ecosystem, and also there are partners that help Open Hardware Group curate the organizations and the ecosystem. So, to conclude, how Tristan contributes back to the European roadmap that Matthew just introduced. So, at the end of Tristan in 3 years, in 2.5 years actually now, there will be many APIs that are based on RISC-V, both open and closed source, that will range from domain-specific accelerators for a specific, for example, market segment that can be automotive, all the way to software and platforms and EDA tools. This will make Europe stronger because the portfolio of IPs that Europe made, it's stronger. Many of them will be actually open source as an amazing part of the Tristan project. Around 10 of them will actually be CPUs and peripherals, buses, interconnects that will be maintained by the Open Hardware Group. So the weaknesses now will be less. And Open Hardware Group and Tristan collaborates together on this part to take these IPs, which are the open source ones, at a high level quality, so ready for production under a permissive license. Thanks a lot.
Thank you, Davide, for your presentation. We will hear from you again in the final session. So our third presentation today will focus on all within the open source hardware landscape. Without further ado, I can quickly give the floor to Frank Gerkainak, the director of the Microelectronic Design Center within ETH Zurich. Over to you, Frank.
Hello, let me just switch on the mic. Yes. So I just want to introduce our project. I work on parallel ultra-low power platform. This is a research on open source energy efficient computing architectures. And actually we are celebrating 10 years of our project this year. The project is led by Luca Benini and involves ETH Zurich in Switzerland, as well as University of Bologna in Italy. We are a large group of almost 100 people. This was from our celebration just this month. And we have designed and tested more than 50 ICs related with our project using different technologies. And if you're interested, you can check from this link all our chips. Some of them are very complex designs, like this is the recently taped out Okami, which is a chiplet-based design, has a couple of hundred RISC-V cores running at 1 gigahertz with an interposer currently waiting for the assembly to finish. This is how it should look like, hopefully. And you can also read more about that. Now, all of our designs are based on open source hardware, and we are using GitHub under a permissive license to distribute what we have made. That includes HDL source code, test benches, software development kits, and virtual platforms. So a permissive license allows anyone to use, change, and make products without restrictions. What we do provide ends up being a box of building blocks. On one side, you have the RISC-V cores. We have developed over the years a couple of different ones, 32-bit and 64-bit, but that's not enough. You also have peripherals, interconnect, accelerators, and then these all join to come together in platforms. They can be really simple, where a small accelerator, one RISC-V core, a bit of memory, and some peripherals. So these are single core systems. Can be multi-core systems where many cores work as an accelerator, or scaled up systems like the previous one that I showed you, which was Okami. So it covers a wide range from IoT all the way to HPC. Now, how do we collaborate with third parties? How does this thing help other people? So there's a partner that here is us. And we actually have all our outputs at GitHub. The partner may take it, clone it, and if they are nice, they might even make some comments or raise some issues, or they can just take what is available and work on their custom designs. Obviously, using projects, industrial projects or European projects, there could be co-sponsored resources that builds on what is available. Tristan is a good example, and they can, together with different partners, we can improve what is available. There is also a possibility where we say, okay, you know, this is something important for the company. They don't want everything to be open, and there could be a private cooperation. An example of this is what we did with Green Waves. It's a startup in France. We have our own design, which is open. They took parts of it, added their own secret sauce. We were also involved in supporting them with this thing, created a product called Gap 8. There's a follow-up project called Gap 9. It's not only direct industrial collaborations. We have a number of them. Davide was actually involved in this one with QuickLogic, was an eFPGA. This is the Green Waves I was talking about. Same with Dolphin, or recently we also had a collaboration with Meta, all based around the open source repositories we were talking about. But it doesn't always help us. We've seen many works published by companies such as IBM, Intel, Google, NVIDIA, have their research or developments done over open source releases we have. So these companies didn't work with us. They saw and they used the open things available and developed their projects. What I want to say is in the last 20 years, IC design has changed a lot. So this is when I started at ETH, one of the designs I was involved in. And these two dies are to scale. On the left, it's 0.6 micrometer AMS technology. On the right, it's GF22. And you can see that the core of the chip fits barely in the octopus's eye there. There's a scaling of 4,000. Consequently, what used to be a complete chip is now a very small part of an SoC. So if you're talking about the RISC-V core, you have a host domain that supports a memory subsystem, external memory sensors, and there's also a software component to it so that things can work. And if you're making a heterogeneous acceleration, something more exotic, maybe you're adding an accelerator to it, and for that, the software space has to be extended. Now, in a normal project, you will probably be interested in contributing to only a small subset of this system. You want to develop a new DMA that requires a kernel or some hardware acceleration, whatever. What you can do if you have some SoC templates, you can concentrate your work where it counts, meaning that you take everything else from available open source repositories and put your effort in things that are of your interest. Now, it is nice in theory, but I just want to go over what are some of the challenges. So from your idea to a chip, usually you have an architectural description that's captured in RTL. You use a synthesizer to get a netlist, and then you have a placement and routing flow to get a blueprint that will then, through a fab, be manufactured as a chip. Now, this gets a little bit complicated because the fab has some information that allows the physical design to complete. There are libraries involved and third-party IP that comes into your designs. And of course, there's a verification component. Now, our current efforts are able to do the RTL part. We are pretty good at this part. But what limits us these days are what EDA vendors are involved, and they might have something to say about the output of their tools. There's also the fabs that have this documentation, which they are not always making accessible. And third-party IP may have restrictions about how the further down designs can be made accessible. So there are solutions to all of them, and there is many people. We play our small part. There was discussions about Europe getting more involved through, for example, Europractice IC service. In Europe, IHP is open sourcing its PDK, and there are various actors working in the open source EDA flow to make everything more open. So we are getting there, and first fully open chips are underway. This is one of our projects called Iguana. We hope to tape it out just next month, actually in 2 weeks. And some parts of this design you see still rely on proprietary tools and IP. We hope that the next version of this will be done fully open. So the next part is what is a problem for us as a university. We are motivated to develop new architectures and systems. We need these cores, but we are not so good in providing industrial level support for these cores. So we need help. And we are very happy to receive this help from the Open Hardware Group, like Davide was talking, EU projects, Europractice, so that what we develop can be maintained and kept for Europe for a longer term and and developed into products. So in summary, open source hardware is making great strides. The RTL level open source hardware is quite established. Among others, we provide a number of solutions that are widely used in industry and academia. More openness requires solutions for technology, EDA, and third-party IP providers, for all of which there are some solutions. And in 5 years, we will be in a much, much better position than we are doing now. The non-profit organizations, supporting groups, different EU projects. But what we shouldn't forget is IC design is an expensive business. There will always be a financial aspect. So open source should be seen as an enabler that lowers cost and access, but will not be able to make IC design free. The business itself is very costly. So more work and support is needed to make open source hardware viable. I thank you very much for your attention. If you have any questions, I'll take them later. And thanks a lot.
Many thanks, Frank, for your contribution. So before we keep going, moving forward in our packed agenda, and come back at the end in our discussion, I wanted to check in with the chat. I think we received a couple of more practical, technical questions that we have been able to solve. Last one from Satya. I think unless any of the speakers want to answer right now, maybe I can ask Satya if there is one of them that you would like to address your question to, and then we come back to it after in the next presentation or right before the panel. So I think we can move on to our next presentation. We have with us today Teresa Cervero from Barcelona Supercomputing Center. She will present today about the open source silicon and accelerator design at BCC. Over to you, Teresa.
Thank you, Davide. Hello, everyone. I'm Teresa Cervero. I'm a leading research engineer at BSc, and well, since I've joined to BSc, I've been working in a European project, MIP project, as a hardware coordinator of all the different activities there. So from RTL verification to FPGA emulation. But here I would like to provide an overview of what we are doing at BSc on the how do we contribute to the ecosystem, how we try to do it. But of course, you have to understand first what is Barcelona Supercomputing Center. So for us, it's a public organization focused on research for high performance computing. It's a consortium of 3 different entities participated by the Spanish government, the Catalan government, and also Universidad Politécnica de Catalunya, with the goal of first providing supercomputing services to the Spanish and also European researchers, offering them computational resources with all the different infrastructure that we have, the Mare Nostrum. But also we want to tackle different problems. And for that, we are focused on research and development in computer science, life science, earth science, and also in computer application in science and engineering. Actually, also BSc is structured in these 4 departments, trying to cover all the topics on those different domains. And of course, as a research institution very connected with the university, one of the goals here is to offer training and education through PhD programs, technology transfer, and public engagement to make the society understand what we do. Then, how do we see the future in high-performance computing in Europe? Well, we see the future open. Actually, you can see this image try to represent the current state of the HPC in general. And as you can see, most of the layers are open. So we have a long tradition on contribution and all the different layers from software application, libraries, schedulers, compiler, operating system. Actually, we have learned a lot from Linux, and it's the facto standard operating system in HPC. From software, what we have learned is that open source brings a lot of benefits. Of course, it provides a common platform with the specification and interfaces. It accelerates building new functionalities, and it also permits the community to contribute and make this everything, all the APIs, better and broader. But what happens with the hardware, and more in particular with the processors or accelerators or infrastructure perspective, what happens there? Well, we are not still there. It's well, as our previous speakers has mentioned, there is a lot of work done, but still not enough to consider these layers open. So we want to, or we ambition to move from those close to an open system contributing in hardware, because it's true that we are in an earlier stage in hardware, as also considering what Frank or Davide have mentioned before. But however, we can do it. And RISC-V, in this case, proposes a really good alternative for Europe to develop on top of that. So it's an open standard. It's help us a lot to work in a different way, to propose new solutions. It can be extendable, it's license free, and there is a lot of people working on that. So it also helps to enlarge the ecosystem around it. So as we listened some weeks ago in the RISC-V Summit Europe, RISC-V is inevitable. So for Europe, it's the alternative with respect to other ISAs. If we take a look to the HPC stack, we can see different levels of maturity and at different levels. And as you can see, again, software layers are more mature than hardware. Although in HPC, and even more if we think, if we start working on RISC-V, the application layer is not still very mature. So at BSc, we want, from the hardware perspective, we want to strengthen these two levels, from application to hardware, and also from hardware to application. Of course, keeping our identity on software in HPC. So we need the rest of the layers, but let's talk about hardware. So the vehicle or the instrument that we want to use to strengthen the maturity, propose a new solution is LOCA, which is a European laboratory for open computer architecture. Here, what we want is to provide training and strengthen collaboration in Europe. So offering traditional master training, PhD, but also having some collaboration internships from students here in Barcelona to other centers, even industries, or bringing people to the center. So it's an ideal sandbox for creative and innovative work. As you can see here on the left, we have a castellar. It's something very traditional in Catalonia, and LOCA has the same purpose. So build on top of a very strong base, and little by little, in an incremental way, offering good solutions. So how do we want to do this? Well, we have HPC applications. As I mentioned before, we have different departments focused on different problems and trying to get solutions to those. And what we want is to offer solutions trying to accelerate those, or at least partially some of those applications in hardware. So that obligates us to design new HPC architectures to tackle those problems. And then running those running those applications on top of that hardware and learning on the process. So we can create this flow of software, hardware co-design, learning from applications, learning from the hardware, and creating this nice circle of collaboration. And this can be seen only internal to BSc, but also we are participating in European projects and with other entities to do this in a very open way with the community. If we are more specific in Europe and European projects, BSc is participating in several ones. So we started on hardware with EPI, so European Processor Initiative Project, a few years ago. And the goal of this project was to create, well, an EPAC, so creating an European processor accelerator. Here, the idea was to create, to develop RISC-V accelerators for vector, stencil, and variable precision with shared cache L2. And then the next project we were involved is MIP project, is the one I've been working these years. And here the main focus is to work on a system from an infrastructure perspective, and also provide as a digital laboratory for pre-silicon validation of European IPs, but also as a software development vehicles for software developers. In parallel with that, as part of MIP, we have proposed an accelerator where we have used open source IPs, some of them coming from the DRAG project, which is a BSc project that generates or that designs a family of RISC-V IPs. The next project is eProcessor, and here the idea is not only working on an accelerated RISC-V accelerator, but also introducing a RISC-V processor on a system and moving from in-order to an out-of-order processor. And then in the EU pilot, the idea is to create a pilot for a European Processor Initiative. And here it's using local and open technologies and creating an open compute platform infrastructure also. And next, who knows, right? But the idea here is always growing together little by little in collaboration with our partners, and of course using and reusing the previous infrastructure and IPs that has been developed. So what's the vision of BSc of the future in HPC in Europe? Well, we started in BSc with Mont Blanc in 2014. At the time, we were working with ARM and it was European. But later on, ARM was acquired by a Japanese company. And 7 years after that, a big investment, they developed Fugaku, so supercomputer, which is in the first in the top 500 ranking. But what happens? Why cannot dream on having a RISC-V supercomputer in the future based on European IPs? Why not another Mare Nostrum? We have, well, soon this year we will start working with Mare Nostrum 5, but why not in the future with Mare Nostrum 6, right? We want to contribute to this design and develop RISC-V IPs for making that real. And for that, of course, this is a possible Euro HPC path to get there. So we have started with some calls based on RISC-V, where all these products that I've mentioned fall in, and we will finish with the EU pilot project with a demonstrator of that. But in parallel, of course, new calls can be open to continue working on data strength and creating pilot of target accelerators for future for solving future problems. And of course, that can be a flagship for future ideas that can help us to create the European supercomputer. And of course, in the first iterations, it's not going to be competitive, but why not, if we continue pushing in that direction, having the European supercomputer based on European IPs. Again, we cannot do this alone. And alone, I mean, not only working with European partners, we need to learn and share with with others on this. And with that, I think that's all. Thank you very much for your attention.
Thank you. I think we're adding interesting elements and perspective, and to give a more complete picture of the situation. So to continue in this direction, it's time to hear now from Andy Moore from Risk5 International. Andy, over to you.
Thank you very much. Can you see my screen okay?
Yes.
Great, thank you. So yeah, I'm Andy Moore. I'm a senior marketing manager at Risk5, based in the UK, and a lot of these talks have been very, inspiring to see all the detail of what's been happening. I'm going to be speaking, I think, at a bit of a higher level, so a bit less detail, but just some background information about Risk5 and open innovation. So from the pandemic to everyday technical challenge that we see, we work best when we work together, and open standards and collaboration help us create new technologies across industries and geographies worldwide. And now open is coming to computing. Risk5 is an open standard instruction set architecture. So think like Bluetooth or TCP/IP. Think of us like that. The ISA is the protocol between the hardware and the software. Essentially, it's essential that the industry builds and shares an open global standard so that the many stakeholders engaged in this effort can work cohesively across the Risk5 ecosystem. In 13 years, the community has grown from a small group of enthusiasts to over 3,500 members collaborating across 70 countries worldwide. Risk5 International produces specifications. We don't provide any implementations of Risk5 hardware. Risk5 implementers create their own hardware or simulator software that is compatible with Risk5 ISA specifications, and those implementations can be open source or commercial. Risk5 community is working together to create ISA and non-ISA specifications, and Risk5 encourages individuality, differentiation, customization, whether it be in how the ISA is implemented or in adding custom instructions. And often what starts as vendor-specific custom set of instructions eventually becomes part of the standard. Collaboration is critical to our shared success. And just as we encourage collaboration within our community, Risk5 works very closely with other non-profit organizations and open source projects, including Open Hardware Group, as we've seen today, CHIPS Alliance, and Low Risk. These organizations provide open source implementations of the Risk5 ISA. Risk5 really benefits greatly from rich history of open source. Risk5 has redefined the future of computing, becoming the most prolific and open ISA in history. I'm going to talk to you about three things. One, Risk5 is inevitable, as Teresa just said. Across computing, from the lowest power embedded applications to HPC to data center, people are excited to unlock new possibilities using Risk5, and we see investments happening across all markets. This is a critical point in compute history at the moment. As we've seen before in open source software, open standards are taking a hold, and this is why Risk5 is inevitable. Number two, Risk5 enables the best processors by design. By taking a truly modular approach, as you were hearing earlier, you have much more freedom in your design, enabling you to be more competitive and more differentiated and tackle challenges that you couldn't on other architectures. And number three, Risk5 is rapidly building the strongest ecosystem. It's taken other architectures decades to accomplish what we're accomplishing in only a few years together. This is made possible by the collective investment of our community. So to go into a little more detail, over 10 billion Risk5 cores have shipped already. Last year at Risk5 Summit in North America, Qualcomm on stage said that they've already shipped 650 million Risk5 cores. We're seeing innovation and adoption across the compute spectrum at every performance point, from low power to HPC. The collective investment we're seeing reduces the strategic risk of using Risk5, and we're engaging the entire ecosystem to grow much faster than ever before. You can see how fast the adoption of Risk5 is happening. The Risk5 market share of semiconductor IP is forecast to grow from 1% to 16% by 2027. Semico Research forecasts that 62.4 billion Risk5 chips will ship by 2024, and that's the strongest growth is underway in AI with 25 billion Risk5 SoCs produced by 2027. Jim Feldham, president of Semico, says that companies are turning to Risk5 solutions for a wide variety of applications and to address a wide range of performance and volume requirements. Risk5 enables the best processors. Other architectures can be a poor fit. They give you baggage and features you don't need, or don't let you enable or customize the design features that you do need. RISC-V helps you differentiate by enabling a new variable of design freedom in a way not previously possible. This flexibility and freedom increases your potential for innovation. And using RISC-V, you have the support of a massive community, enabling you to concentrate on your value add and your innovation. We're rapidly building the strongest ecosystem. There's a collective investment from across our ecosystem. We're taking a very thoughtful approach. For example, we're specifying a single hypervisor standard to simplify and unify application support. We're taking a very modern modular plug and play approach. We have already over 10,000 software developers on RISC-V already. You can explore our ecosystem on the RISC-V landscape. This landscape is intended to provide insight into the rich RISC-V ecosystem available today. And we're inviting submissions from any project supporting RISC-V. Some of the ones you heard about earlier are already on here. This has only been online for a short while, but you can already see the breadth and depth of support across a range of categories, such as applications, libraries, infrastructure, runtimes, operating systems, hypervisors, design tools, compilers, verification, and also implementations, which include IP, single board computers, accelerators, and chips. This ecosystem of projects, organizations, and companies provide the technologies and support to accelerate your design and concentrate your money, energy, and time on your specific innovation. And this is the key to how RISC-V leads on innovation. Building on a common foundation, every implementer can add their differentiation. We're driving the definition of extensions using quantitative and software-driven methodologies to benefit domain-specific software workloads and coexistence of vendor-specific extensions. Upstream support for vendor extensions unlocks performance for novel applications. Profiles and platforms are simplifying our user our developer journey. Software is a key focus of our attention. Compatibility and portability of workloads is essential, and it's for this reason that we've been working as a community on RISC-V profiles. These profiles define versioned collections of instructions, behavior, and state that enable application portability between implementations. And we're also building a contributor culture. Member companies are joined together to build the best open source ecosystem. We collaborate closely with major open source projects to align our standardization and member contributions with each upstream project's processes. There have been nearly 50 different ISAs over the years, and ARM and Intel accounted for nearly 100% of the market in 2020. Now RISC-V and its community is being adopted across a range of markets, and here are some examples. We're seeing in automotive, Counterpoint rather expects that RISC-V will capture 10% of the automotive market by 2025, and we've already seen some design wins such as Mobileye, and we have a range of companies here supporting RISC-V in automotive and the essentials that comes with, such as functional safety and security. In terms of high performance computing, we've heard about a lot of this already today. There's some great projects going on. Barcelona Supercomputing, Teresa was just telling us about that. We've got significant investments in multiple geographies specifying RISC-V for HPC. And in the data center and cloud, Meta just recently announced that their MTIA version 1 AI accelerator uses 2 RISC-V processor cores. So that's very exciting. We have a range of different companies, again, developing processors for data center and cloud applications. And we will see the RISC-V CPU core market grow 115% CAGR, capturing over 14% of all CPU cores by 2025. AI and ML is a large area of development as well. And we see a lot of different RISC-V member companies here, from Semidynamics, Andes, Codasip, Sci5, Esperanto. There's a lot of activity here in Europe on AI and ML. And we see RISC-V-based SoCs for AI growing 73.6% CAGR to 25 billion units and $291 billion in revenue by 2027, according to Semico. We've already heard about a lot of these projects already today from the previous speakers. Europe is deeply investing in RISC-V. There's a lot of great stuff happening. Tristan Isolde, the Euro HPC joint undertaking, call for proposals being out. European processor initiative and what Frank was talking about earlier about the pulp activity between ETH Zurich and the University of Bologna. What was really exciting was that last week we had RISC-V Summit Europe. Many of the people on the call here were there, were deeply involved in organizing, and thank you very much for that. It was a great event, very busy, as you can see in the photograph here. If you want to find out more about what happened at RISC-V Summit Europe, keep an eye on the website, risc5-europe.org, and also on the RISC-V YouTube channel. There will be content going up there from the speakers, and it's going to be a really, really rich snapshot of what's going on in the European community just now. So I encourage you to go back to there. And if you'd like to work out what you want to keep an eye out for, if you go to the RISC-V Europe website and have a look at the conference tab of that, you can see the different speakers, the presentation titles, and also abstracts. So in terms of membership, RISC-V is more than 3,000 members in our ecosystem today. As you can see, we're still growing at a fast pace. In 2022, we grew 30%, which is really amazing. And we're truly worldwide. So membership split basically a third in North America, a third in Europe, and a third in APAC. And the benefits you get from that, from joining our community, you get basically, it accelerates your technical traction and insight, and you get to contribute to the technical priorities, approaches, and also code. You gain a strategic and technical advantage in your development and also increase your visibility, leadership, and market insights. Our rich ecosystem enables you to build your network of innovation partners and also your customer pipeline, and the opportunity to deepen, engage, and lead in local and industry developer networks. So RISC-V enables you to showcase your RISC-V-based products, services, training, and resources using resources like the RISC-V Exchange, which is on our website, where developers can search for RISC-V technologies, and you can also get access to placing stories on our blog and our news sites. RISC-V is a community of passionate, dedicated, and invested stakeholders. Individuals, companies, universities, public institutions, nonprofits, and nations are all getting involved as one global connected movement. As I said at the beginning, we work best when we work together, and open standards and collaboration help us to create new technologies and across industries and geographies worldwide. We've seen before in open source software that open standards are taking hold. This is why RISC-V is inevitable. If you'd like any more information, please visit our website or contact me at andy@risc5.org.
Thank you, Andy, with this powerful takeaway. I think we can say we have set the scene for an interesting discussion with our presentations. And since it's time, we're a bit late with our agenda, but it's time for me to give the floor to Elena from Open Forum Europe and invite all the speakers you have just heard with the addition of Michael Gilda to our panel discussion. Over to you, Elena.
So hi, everybody. Thanks for being here today. I'm a project officer of Open Forum Europe and part of the ALLPROS consortium. After all those very interesting contributions, I would like to open up a panel discussion with you all that tries to analyze and reflect on the open source and open innovation approach within the semiconductor ecosystem. So we will mainly focus on the potential for innovation, but also for research and for specific key stakeholders, as for example, small and medium-sized enterprises are very relevant to the European Union. And yeah, having said that, most of our speakers already have spoken before and will join us in this discussion, but I also want to introduce you to Michael, who will join us now from Antmicro. Michael, do you want to introduce yourself shortly?
Sure. VP Business Development at Antmicro. Very happy to be here. Working on open source hardware since many, many years. Member of the RISC-V International Chips Alliance, Zephyr Project, and a bunch of other organizations in the space. So yeah, very glad to be here.
Thanks. So I will attribute my first question directly to you, Michael. I want to ask you, what strengths does the approach of open innovation with a focus on open source hardware in the domain bring to research and innovation in the chip ecosystem? Why is the approach often referred to a catalyst for innovation nowadays?
Well, I believe this answer kind of needs a multifaceted response, and I'm sure my colleagues will add a bunch of thoughts here as well. I think primarily open source is meant to be not in opposition to other things, but rather kind of building out, on things that are not possible otherwise. And with open source, kind of you get the freedom to do whatever you want, because you take things and you use them without necessarily having to even talk to the people. Of course, it's encouraged for you to work in a community, and that's what organizations like Group5 International are trying to enable. But a lot of innovation actually happens when people just have great ideas and they try to poke at them for a while before sharing them with the world. And they start working on things without having to sign a lot of deals, contracts, NDAs, whatnot. They take some tools, they take some IP, they try to build something. And of course, like after a while, they realize, okay, to actually build something, I need to collaborate with others and so on. But there's a long stretch of time, as we've observed from our experience, where people tend to try to do things without necessarily having to, explain themselves. That's a good thing for innovation, because like you want to innovate in the way you want, right? And open source gives you this fantastic opportunity to vertically integrate things that you do. I guess also perhaps in the hardware space specifically, a lot of people complain that hardware is slow and hard and not like software. And I would say that part of it is kind of self-imposed, in that, of course, part of it is just because hardware is indeed physical and there are some barriers. But part of it is also because hardware has not yet fully embraced, what software has realized a long time ago, where the more open things get, the faster everything advances. I believe if we had more open source in the hardware space, and of course we're getting there. There's a lot of progress, but I think there's still a lot of stuff to do. We would actually get a lot more innovation. We would get more software-oriented people involved, and we'd get, just a faster pace of progress, more productivity improvements. I think that there's a lot of productivity that we're losing on reinventing the wheel, or just using, old tools that are not designed with the latest and greatest, capabilities of software engineering. I think hardware will unlock a lot of great productivity gains in the nearest future. So I'm very optimistic, and I think, open source is really key to that.
Okay, thanks for the insights. Does somebody of the panelists wants to add something? Andy, maybe, or Teresa?
I agree with. I agree with what Michael was just saying. And just to reiterate, you get to build on the contribution of others. The community aspect. This is really important, and people are developing technologies that can help you and enable you to concentrate on your specific value add. So yeah, I think that's really important, and the ability to extend the architecture and make it do what you want is really important as well.
If I might add something, and we also need a very good communication, a fluid communication between academia, research institution, and industry, because we need to solve. Usually in Europe, we work from research and then we move to companies, but it's not always like that, because as researchers, we like to do crazy things sometimes, test crazy ideas, because we like to do that. But also we need to tackle real problems that need to solve social issues. We want to contribute on that, and to really understand what the society needs. We need to strengthen that communication between academia, research, and industry to make that real. But also not only because we want to create new products to solve problems, social problems, but also because we need to understand what are the necessary skills for the future engineers. And we need also the feedback from the industry to understand what's lacking and what is necessary to get there.
Okay, thanks a lot. You already touched a bit on also potential weaknesses that come with having a very broad integration of open source approaches in the domain of silicon or semiconductor technologies. Can you imagine other difficulties or weaknesses that we should aware of when it comes to, having a unified approach? Yeah.
Well, actually, some of the weaknesses and strengths were mentioned in the previous presentations. And one of them, of course, is because of the immaturity, let's say, of the open source in hardware. Well, we don't have very mature or competitive IPs, for example, in hardware, and we also lack of the reliability from the industry or even from the society when they want to use them. So we need to work a little bit more on that. Actually, all the projects and all the contributions of the different institutions, industry included, are making changing that, and then trying to get more people involved in the open source hardware ecosystem. But we cannot forget, of course, the software layers. Okay, so we need to keep in mind that hardware without software, it's nothing, and also the software needs hardware. And if we want to accelerate things and also save energy and those things, we need to, again, work together on those. From the strengths that I've seen, I mean, I don't have a lot of experience. All my colleagues here in the call probably have much more years of experience than me. But what I've seen in Europe is a really nice sense of community and culture of sharing ideas. And that collaboration makes things moving faster. So that's something that we have to consider. Something that we will need to improve from my perspective, again, is the lack of engineers. So it's great that we can improve things, but if we don't have future generations of engineers, what's going to happen? So we need to make better marketing, let's say, for attracting more talent and retain that talent in our institutions, companies, and making and visualize that all what we do makes sense and it's really cool.
Thanks a lot, Teresa. Does somebody want to directly answer to what Teresa just mentioned? Otherwise,
perhaps like one thing to be said about education and getting more engineers in the space is exactly one of the strengths of open source is just the ability to freely share all the outputs and collaborate between, I think the concept of collaboration between academia and industry and this disconnect, between like people do stuff in academia and never gets commercialized. It gets easier if the outputs are open source because like the commercial entities can actually grab the outputs. That has happened to the ETH Zurich work output a lot, right? Even companies just taking things and not telling that they've taken them and turning them into real kind of commercial products. That's exactly what's supposed to happen. Of course, like ideally people do communicate and actually collaborate together, but open source has this interesting capability of allowing people to do whatever they want. And sometimes, very interesting results appear even though, there hasn't been a direct relationship between the origin of the created IP and, its consumer on the other end.
Maybe I can add actually on Michael's comments. It's right, but it's not only industry taking from academia, but it's also an opportunity for academics or students. Actually, if they're directly working with what the industry is actually using, they are kind of ready, to step into the industrial market because they will be working with the same IPs, with the same infrastructure, with the same concepts. I mean, of course, not 100%, not in all the ways, but there will be commonalities and let's say a background which is common for both, and they will collaborate from a position that makes the students stronger, more ready if you want to tackle the industrial challenges. because they know more IPs. They didn't play with toy examples at universities, and they go in a completely different environment with completely different IPs and flows and tools and software stack on building a new product. But you are kind of bridging the gap between the two. Of course, you will tackle different aspects of that, but you have a stronger background as a student.
I can also add something. I mean, as I try to explain, the SOCs, modern SOCs get very, very complicated. And this means that any one institution, even let's say a relatively large institution like ours, is not able to do the entire design themselves. We need the help of others to put things together. And open source just helps this and helps our students, our researchers, to work on things that may still be relevant for the industry. Even if there is not a direct transfer or we use slightly different things, you get ready in this environment. I think it is necessary to be able to work with this. I mean, open source is one way. There could have been others maybe, but at the moment, I think this is our best bet.
Actually, I have a follow-up question, which comes originally from the chat, from Satya Sahu. She is asking a very specific question regarding the support of EDA tools. So the sorry, the automated design, electronic design automation tools. A little bit nervous. So actually, I think this question was targeting more into the direction of the European Commission in terms of what professional funding and support is foreseen. But is this also something that you, as coming from very different stakeholder groups, can refer to? Is the EDA tools question a bottleneck so far? Goes in the open round.
I can try.
Nobody wants to answer this.
No.
I mean, a solution is needed, right? I mean, let's just be fair to it. Whether or it won't be easy, it won't be immediate, but we need a solution. So there are some, let's say, BSc has the resources, ETH has the resources to maybe set up this infrastructure within themselves. But there will be a few institutions in Europe if you do so. So if you want to go forward, if you want to be serious about this, you also need to provide some sort of solution. What the technical details of it is something. It shows actually the commitment of the Commission to try to tackle this problem. It's brave, I agree. It's probably going to have a little bit of minefields here and there that needs to be navigated, but doing nothing is also not going to solve it.
Yes, exactly. Actually, we have seen in previous presentation by David in this case, Tristan is trying to tackle that. So creating a whole ecosystem with tools that can be used and reused for current and future developments. But it's true that sometimes we have the we get a struggle with the EDA tools because of the NDAs, or you cannot open source your code if you use this or that tool, and it's hard to develop an EDA tool with with the industry that fulfill industry requirements. But I think there are a lot of people contributing in that. So it will take time, that's for sure. But we are doing baby steps, to move in that direction.
Yeah, as Matthew mentioned, there's a plan for the European Commission that is starting from the 10 years plus. So that we should have in mind that we won't be ready tomorrow. It takes time, it takes resources, it takes ideas. Global ideas, actually, because it's open. Let's not narrow ourselves about Europe. We care about Europe, of course, but ideas come from all over the world. And
I think in the area of tools, what needs to be said is that, as everyone has kind of highlighted, it's a hard problem and it's not solved overnight. But there's a lot of things people are not looking at, like productivity increases that, you know, they don't necessarily require replicating the existing tools of open source, but like there's a field for new tools that just make people more productive. AI is one space in which, you know, kind of a lot of good stuff has been done with open source. And so in the nearest future, of course, we have to foresee a mixture of closed and open tools. And it's just going to be like that. But like our ambition is to just make things better with open source, like add on top of what's already there. And that's what we're doing, for example, in the Chips Alliance, which is kind of has a bit more focus on tools themselves, where we're looking for areas in which we could just make the world better. And there has been areas like this, whether it's kind of code development, like linting, formatting, and so on, whether it's, you know, kind of getting some early results from open source tools that allow you to be more productive with other tools. There are definitely ways in which open source can be used to augment, you know, traditional flows. And then, of course, over time, you can think about completely new ways to design chips, again, with machine learning and so on. But that is, of course, a long-term process. But it doesn't mean we shouldn't try to tackle it. It's there's a lot of opportunity there long-term.
Thanks. Very interesting contributions. Michael, I have a follow-up question regarding what was just tackled a bit. From the perspective of SMEs and smaller companies, are there some other needs within the value chain that should be, you know, supported in a stronger sense within Europe?
I guess it's kind of course, a long answer to be given here, but generally speaking, if you're working with open source, if you're looking at how do I innovate with open source, I believe that awareness goes a very long way. So just like highlighting the awareness of what's already there and what can be used today is important, because we don't want everyone, I mean, we do want some level of, you know, innovation where many people do the same thing because they approach it from different angles. But at the end of the day, it's very good to also pool resources where you can. So just kind of learning about what's there is kind of very important, because you avoid accidentally, you know, having to do things that have already been solved. So I encourage everyone to, of course, look at, for example, what ETH3 has done and so on. It doesn't make sense to try to do exactly the same thing over and over again. Secondly, you know, there's a lot of stuff where there's common needs. It's not like you're the only company in the world that needs this, right? So you should definitely look for, are there any big stakeholders on this market, you know, of hardware in general, who have common goals with me? And open source has this nice feature of being able to find common goals, even if you're nominally competition sometimes, but typically, you know, many companies are not really competition of each other. They're just like in different fields, but it turns out they might need the same thing. A good example is Calyptra. It's a root of trust project that just joined Chips Alliance, and they're, you know, a bunch of companies who could be traditionally viewed as competition, but also like just in neighboring fields are working together to build a root of trust. And they could do this, of course, individually. Each of them has the capacity to build a root of trust. But if you build it as a group, if you contribute to the same kind of pool of IP, and you make it all open source, and you make kind of the entire, you know, ecosystem for Calyptra as open source as you can do it, you actually enable a wider use of this and better quality. You know, there's a lot of advantages, and companies big and small benefit from this, and big companies benefit from it in a different way. But generally speaking, the small ones can definitely try to look for, are there any bigger companies than myself that have the same problem? And I'm sure there are, right? Like there's almost no way you're so niche that there's nobody else in the world who has the same problem. Or if you're so niche, then perhaps your company is in danger of another kind. So typically, kind of open source allows you to find those allies and try to work with them. And of course, like how to work with them is another topic. Like it might be through a body like Open Hardware Group or Chips Alliance or RISC-V or whatnot, or it might be in EU projects and so on. But I believe that identifying common problems and also identifying what's already there, what problems have been solved, is extremely important. And perhaps lastly, just not being afraid to get external help. Like that's why companies like ours are there in general, where kind of if you need help in navigating the open source landscape, there are people and companies that have that expertise and can just offer that to you. So yeah, I guess the most important message here is don't just do everything alone, because open source has this ability to enable that, as opposed to other approaches that perhaps where you really would be on your own and perhaps at the mercy of whatever suppliers you have. Whereas in open source, you actually have a much broader wallet, so to say, of solutions to choose from.
Yeah, thank you very much for highlighting the strengths of collaboration, also the need for collaboration. Our next question is more of a strategic policy nature. I want to ask Davide, who is part of the Tristan Consortium, if you think that open innovation is a viable contender actually to increase Europe's stake in the international semiconductor market, because that's the objective of the EU within the next decade. Is the openness angle actually something that is coming also, or could also come with potential negative effects for certain stakeholders that we should be aware of now?
Well, good question. Thanks a lot. And negative effects are the weakness we've been mentioning since the last hour, right? So as of today, we have many weaknesses to tackle. So first, we don't have a large portfolio of IPs. So if I want to make a product today, I may not have all the ingredients coming from open source, just at the level of, for example, in the slides that Frank showed, just at the level of RTL IPs. Then you have all the supply chains that Frank showed, where you have EDA tools, foundries, files, libraries, and so on. Those are still closed source. So rather than a negative effect, I see weaknesses as today. So it means that we're not ready yet. But focusing more on the strength, we definitely, if we look at the other way around, we build way much more than in the last few years to cope with the market and the European projects, the CHIP Acts roadmap, but in general, globally, the direction is with a positive derivative, right? Which is making more and more open source IPs and EDA tools, software stack, and all the ingredients you need to go from application to GDS. It's something that is going to happen in decades, but I think it's going to happen. And so I think open source is positive. I can see a negative effect itself. I see weaknesses today.
But it's true that some people usually mention fragmentation as an effect of the open source, but we can see that from a different angle, point of view, instead of fragmentation, say diversity, because in the sense that you have more possibilities of customize your design. So you have more possibilities of having something very specific for you. The problem that I usually see is the maintenance of the code. So it's, as engineers, after all, when we start participating in the ecosystem, we usually don't documentate a lot what we do, and that makes sometimes hard to reuse and or evolve the IPs that we have, because it's a very time-consuming process to try to understand what is there. Even if it's functional, you don't know how, so you need to learn again how to do it, or how it works, has been done. And reading the code of other people, it's challenging sometimes, always actually. But it's something that we need to teach to, in this case, to our students. So it's part of the skills, the technical and non-technical skills that we also have to include it in our curriculum. So it's not just being able to write code or developing code, whatever it is, but we also need to maintain that code in a proper way, and also being aware of that there are people out there that will need to use it in the future. So you have to be very precise and document things, and learning how to explain what you have done, to visualize the outcomes of your project. So it's not negative effects, but of course collateral effects that can be seen in one way or the other, depends on your point of view.
Yeah. But Teresa, this is what actually Open Hardware Group, Low Risk, Chip Alliance, RISC-V itself, foundations or organizations are actually doing. They gather the interest of many stakeholders, so many companies and universities that see exactly the same weaknesses that you see, so the lack of documentation, maintenance, supports, and stuff like that. So that's why these organizations are born. Now, this doesn't solve fragmentation, because I already mentioned 3, right? So that means at least probably I will have a flavor of 3 IPs that maybe, but that's a good thing. That's competitiveness, different flavors. This is actually what Linux is. There's no one Linux distribution and that's it, right? Linux is open source, but there are, I don't know, but for sure 10s or 20s distributions that any of them optimize or makes the experience better in one corner or in another. And I think this is a good thing.
Don't get me wrong. I mean,
Go on, please.
that's what I said. I mean, some people see this opportunity as fragmentation, but I don't see that it's like that. It's an opportunity, actually. And it's true that these institutions are helping to provide these ways for documentation and maintenance of everything, but also from the academia and research institutions point of view, we need to teach our students, the future generations, to be very precise and to be very clean in the way they work, as we mentioned before, because we need to work with the industry, and they will move to the industry, so they need to learn those skills. And of course, there are a lot of material out there to work with.
Okay, thanks a lot. As we are already quite late, I want to grasp the topic of skills again and ask Frank about his insights at ETH Zurich and also University of Bologna, when it comes to skills and education within the domain. What are lessons learned? What is potential for the future? What needs to be highlighted further?
I think the important thing is to get people involved. You don't learn chip design without making chips. You don't learn working in open source hardware without being involved in it. So there is plenty of work to be done so that people can get involved. There is not one solution for it. I mean, there are some good examples. Some people had some success with the way they are doing things, but there is actually a diversity required, both in licensing, both in architectures, both in solutions, and we need to get people involved. So this is mostly the message, without being selfish. Calista RISC-V was saying the same thing in Barcelona last week, right? We need people to get working, and this is also what we see. I mean, the more people we have interacting with tools, with these projects, the more ideas will come out, and eventually, hopefully, we will have a minimum number of people and ecosystem that can move forward without getting constant funding from government agencies and be sustainable at some point or the other.
Okay, thanks a lot. Does somebody want to make a short comment regarding it? Andy, RISC-V was mentioned.
I think so. We are. I think that's what Frank was saying. Having a self-sustaining membership, and more people involved and then with the technology is something definitely that we're looking for, and we're looking to provide things like training and other resources to help with that. So maybe not quite the same thing as what Frank is saying, but I think we do need to develop the ecosystem, and that's really one of the main drivers of what we're doing. We have places where people can show their technology, as I was talking through on my my section of the talk. We have places where we can where people can look for jobs and share vacancies and that kind of thing, and that's one of the key parts of what we see is what we're trying to do, and also the benefits of membership, because I mean, even like from a European point of view, I think this solves RISC-V is a great way for Europe to try and redefine itself in terms of its semiconductors, but also RISC-V is a worldwide standard, so it provides opportunities around the world for these technologies to then be successful in a broader sense than just Europe. So yeah, I think, as Frank said, we really need to build things out in a successful ecosystem.
Okay. Well, we are approaching the end, or we are already 1 minute late. So to wrap up, I would like to thank you all for your contributions, and the discussion was very interesting. And I will hand over to Davide, my colleague, again. Thanks.
Thank you. So I think, as Elena was saying, we are approaching the end of our event. First of all, I want to thank all the speakers and the EC for being with us today, but also all the participants that have spent time with us today. And a special thank you, of course, goes to Elena that has put all this together with us. I saw more exchanges happening in the chat and in the Q&A box. As mentioned, we can continue collecting your questions, and you can reach out to us and to the speakers through the details that they have shared in their presentation. So the presentation will be shared in our website. You can see here the social media channels for the project. So unless there's any extra contribution from the speakers, I am very happy to have been here with you all today. And again, once more, thank you to all the team and to all the speakers and the panelists. I see some more messages in the chat, but once more, thank you all, and I think we can close the event. Have a great afternoon, everybody.
Thank you.
Thanks. Goodbye.
Bye-bye.